proved by mathematical induction. Actually, mathematical induction, it exists in Peano Axiom. Peano Axiom is some guy in Italy 100 years ago proposed 5 sentences saying that all integers come from this 5 sentences. And actually, before that 5 sentence, you have 3 additional sentences. I write B1, B2, B3. So you don't need to look at the B1, B2, B3. We look at the P first. P stands for piano. So we have 5 sentences. P1 is 0 is an integer. P2 is if x is an integer, then the successor of x is an integer. It means if I have an integer, the guy following this number is an integer. Okay, and I write as a successor. So basically, successor means an integer after the given x. And this means plus 1 in mathematics, but we can always write as a function. We write as sx. S stands for successor because this spelling starts with s. Okay. Ignore this for a moment. Okay. Now look at P3. P3 say that 0 is not a successor of any integer. That means nothing before 0. Okay. We are talking about natural number n, not integer, so no negative number. Okay. And then P4 say that if two numbers have the same successor, then they are the same. That means so if x plus 1 equals y plus 1, then x, y are the same number. Lastly, P5, this is mathematical induction. It says that if I have a set S with integer, and it contains 2 things, 0, and also the successor of any integer in S, then S contains every integer. What the heck is this? This 5th sentence is exactly mathematical induction. So, what is mathematical induction? Is this ugly expression here? What does it mean? This thing is exactly the base case. So, you need to first prove something is true at the starting point. Okay, and then what? And then now, this thing, the yellow part, is the induction hypothesis. I write H, induction hypothesis. And now you see there's an arrow. That means starting from induction hypothesis, the next guy, S is plus 1, right? That means this statement, phi, okay, this is a statement or proposition, is true from the hypothesis. That means using the induction hypothesis, the following step is true. And if this is true, for all the number n, together with my base case, I have this sentence is true for any n. This is exactly mathematical induction. And this belongs to what? Peano axiom, the 5th sentence. So here is an example. How do you prove 1 plus 2 plus 3 plus 4 plus up to n is this? So we do the thing I just told you. So you have 3 steps. Step 1, base case. That means this whole chunk of thing is my phi. Okay, remember, right? I can write any symbol I want to replace this, right? I don't want to say it out loud. I just say this is this, okay? So now I want to prove the base case. Well, I start with 1, so I 1. And then I just prove this whole thing is true at 1, which means 1 equal 1 times 2 divided by 2, which is 1. So I have this. So the base case is true. And then what? I need the induction hypothesis. I write H, right? Which basically means this is true. Now I write symbol K. Then what is step 3? Step 3 is showing that from here, I imply k plus 1, which this is the same as successor of k, which means plus 1. Then I just do this. So from the induction hypothesis, I have this yellow line. Okay, this yellow line is this yellow box. Now I want to prove this is true. So I need to make use of my yellow box to prove this sentence is true. Okay, so here's how I prove. Suppose I want to consider the k plus 1 case, so the statement phi is just 1 add up to the k plus 1, so now I have 1 plus 2 plus 3 add to the red thing. The red thing is a new thing. I want to prove this is true, okay? Then what? This whole thing is just this whole thing, right? And the first k term is true because of the yellow box. I assume it's true. So this is the yellow box, okay? Then what? This yellow box is just this yellow box. I just call yellow box. Now I have this. Well, I have 2 numbers, the same. I can factor them out. Now 1 is just 2 divided by 2, then I have this done. So what I did is I just show this. And since k can be any number, so I just show that for any k, this is true. Then go back to the page 2. I have a Peano axiom number 5, saying that if base k is true and this big chunk of thing is true, then this whole thing is true for any integer. That's how you prove this is true for any integer. Important, I'm saying a natural number, I make a mistake, not this, okay, because if n is negative, this is false, okay? So this is mathematical induction. I think I have 38 mathematical induction exercise. Enjoy. So go back to talk about the funny thing, that is, what is Peano axiom? Let's talk about this chunk of thing. As I said, now you should see some funny thing. What is plus 1? Plus 1 means in a number line, I have a number, let's say it is 4, plus 1 means I move to the next dot. This is the meaning of plus 1. don't think of this as the math you add 1. Think of it as find the successor of this. This is the guy defining what is plus 1. You should not say this plus 1 define this guy. No, it should be successor define what is plus 1. So if you give me 9,000, what's the successor? It's 9,001. I'm not saying 9,000 plus 1 give me 9,001. I'm saying the number after 9,000 integer is 9,001. And I define this as addition. And that means what? That means addition is not the most fundamental operation. There's something before addition. And addition is a higher order version of successor. That means what? What is plus 2? Let's say we have a number 5. What does plus 2 mean? Plus 2 means 5 plus 1 and plus 1. This thing is the successor of 5 plus 1 means the successor of 5. This guy gives me 6 and then this guy gives me 7. That's how you understand what the heck is 5 plus 2. So that means successor is the most fundamental thing. After that you have addition. What's multiplication? What is 5 times 3? It's 5 plus 5 plus 5, right? If I define this using a symbol A, then this is same as A of 5, and then A of 5, and then A of 5. So that means what? Multiplication is just addition doing many times, right? So therefore, multiplication is just defined by addition, so that means the addition is the father or mother of addition. And multiplication is just a higher order version, that means we'll repeat many times. Then in the same sense, you can know it's exponentiation. So what is 5 to the power of 5? Right, 5, 5, 5, 5, 5, multiply, right? I don't write down the whole thing. So again, that means what? I can write down this multiply 5 as m5. I write a symbol called m. Then this is basically called m5 times. So exponentiation is the son or daughter of multiplication. Then you can have something called subtraction. What is 7, 3? It means this 3 times. Okay, now you know the idea. I can repeat this again. Then I have the 5th thing. Okay, that means I do this 4 times. Okay, and then you can keep going on. Who said you can stop until you reach some number that you never see before? It's something called Graham's number. You now write down arrow to represent what you did previously. And then this means what? This means you do how many times of this? You do this many times of the previous level operation, which this guy, you do this many times of the previous operation, which you do this many times of the previous operation. Then you will get a number. And that number has a name. And why this number is so interesting? Because the moment when you have this number in your brain, you will become a black hole. Because this number is very big, that the moment when you know this number in your brain, you have too many information, in other words, too many mass in your brain that you break the black hole limit and you become a black hole. This means what? There's something in the world, number, not infinity, but just a very, very, very big, so big that, I'm sorry, I don't know how big it is, I can only say it's very big. That once you know this number, you become a black hole. But because we are not black hole, by contrast positive, we don't know this number. So this is a funny thing, right? And actually you can keep going on, you can keep drawing a bunch of arrows, and then you will have some number that is so big that we have no way to understand it, but still they are smaller than infinity. And now you know infinity. How big is infinity? P3, P4, P5 mean. What's P3? P3 saying that 0 is not the successor of any natural number. Okay, so that means what? S is the successor of a number n. For all n, the negative of this is true. Okay, and that was P4. If, yeah, this is the same thing, okay, and then the P5. So this is the idea about Peano axiom. And here's the funny thing, using this, you define all the 1, 2, 3, 4, 5, 6, 7. And then because of Peano axiom, you can now define addition. Now you have multiplication, and you have exponentiation. So that means what? This P1, P2, P5 give you all the math in primary school. Then high school, you have fraction, you have what? Decimal places. Then you add other stuff. Now you have all the high school math. And I'm going to tell you later that Peano axiom is not even the most basic thing. Something can prove Peano axiom. And that thing is called ZFC, and I will talk about it later. These two parts, read it by yourself. This is funny. This means why you cannot divide by 0. Okay, read it in your spare time. And lastly, I will talk about proof by geometry. So this is two high school formula that probably you know. How do you prove this? Draw a picture. So what is a plus b squared? Everybody knows this. How do you understand this? A squared is this thing. B squared is this thing. You have 2ab because one is here and another one is here. And this is true because AB is BA. If this is matrix, this is not correct. If this is number, it's okay. What about free term? You just draw A, B, and C. Now you have this thing. So what does it mean? It means sometimes if you draw a picture, you understand what's going on. Suppose, how do you expand this? Then you draw a 3D cube. And this 3D cube have X, Y, Z, and W. But power 3, that means 3D. Then you have a bunch of cube here. Okay, I don't draw it. And you count all of them. It gives you the expansion of X plus Y plus Z plus W power 3. So this is proved by what? Geometry. Lastly, I said in the very beginning, these three gentlemen said that there's no systematic proof. And these three guys are like 100 years ago, almost. I think people are challenging these three people's argument. Very, very recently, there's something called AICE1004. What's that? It's to prove mathematics automatically by computer. That means what? That means turn everything in mathematics into computer program. Yes, you can do that. The background is something called MLTT, which is something you shouldn't look at it because it will make you mad, okay? So if you want, you can click these two links. And here's the funny example. Suppose I want to know what is 1 plus 3. Okay, you type this. This means 1 plus 3. Saying that define addition. Input is X and Y belong to integer class. What is this addition means? It means I have an integer output defined as X plus Y. And then evaluate this function at X is 1, Y is 3. Then it will give you 4. And now here's a funny thing. If you write this in this website, and you define all the addition, subtraction, division, whatever function, differentiation, integration, you put enough thing into this AICE1004 thing. If you give them enough information, then they can just do the brute force search and then they can find new mathematics. This is what people is doing right now. Okay. Originally, there are 3 labs in this module. Lab 0 will release, but because of time, no.